I'm Gayatri, working as Assistant Professor in EC Department at SNS College of Technology. Today I'm going to discuss about the topic which is Poisson and Laplace equations under the unit electrostatic field in conductors and dielectric under the subject electromagnetic fields and waves studied by second year students in the 4th semester. Today I'm going to discuss about the electrostatic potential and how the charges is distributed in the electric field, and with the help of this we can derive the equation which is called Poisson and Laplace equation and boundary condition. At last we can describe about the applications. And coming to the empathy part of the Poisson and Laplace equations, we know that the temperature will be distributed in our electric field as well as in magnetic field in a metallic surface, and water level will be the water level will be there in our river, and we are having no sources related to that, and hills and valley will be representing our potential variations. And with the help of this gradient and divergence and curl, we can derive the Poisson equation which is related to the electric potential and charge density in the region where the charges will be present. And the Poisson equation will be derived with the help of del square V, which is equal to minus rho V divided by epsilon, where rho V, which is the volume charge distribution. The charge distribution will be classified into line charge, point charge, surface charge and volume charge, and rho V, which is related to the volume charge distribution. With the help of this volume charge distribution we can relate our Poisson equation. And coming to the Laplace equation is a special case of Poisson equation where the surface charge distribution will be 0 in the case of Laplace equations, so that the Laplace equation will have del square V, which is equal to 0. It is valid where rho will be 0. The surface charge density will be also 0 in the case of Laplace equations. And relating this Poisson equation and Laplace equation with the help of electric potential, which is E, which is equal to minus del V, where V, which is called as electric potential, and E, which is called as electric field intensity. Once the potential is known, electric field can be calculated easily, and this electric potential relation which will be used in electrostatic problems. And coming to the application part of the electrostatic potential will be used in capacitor and insulator design and semiconductor application and microwave structures and microwave and RF applications. This will be used. And coming to the summary part of this Poisson equation and Laplace equation, the Poisson equations will be derived with help of with the help of volume charge distribution. We have no already, and del square V, which is equal to minus rho V divided by epsilon naught. And with the significance of Poisson equation, which is nothing but it is related with the help of potential difference. The potential will be related with the help of electric field and charges, and capacitance, which is equal to charge divided by potential. And coming to the potential, the capacitor, when there is a potential there will be a capacitance effect. When we are having the parallel plate capacitance, there will also be a electric potential present in that. We know that when the electric field will be present, when there is a charge, the electric field potential will be occurs. The electric potential will be there, and the electric field intensity will be there. When the electric field intensity occurs, the electric flux density will also occurs. With the help of this electric flux density, we can derive the Gauss law, which is the d square epsilon, which is equal to q. When there is a total flux, which will be always equal to the total charge present in that. Coming to the Laplace equation, in the Laplace equations, the charge present in that particular distribution will be 0. So that with the help of Poisson equation, we can derive the Laplace equation, which is called del square V, which is equal to 0, where the surface charge distribution, volume charge distribution, point charge and line charge will be 0 for this case. It is a special case of Poisson equation. And the electric potential and electric field will be related with the help of E, which is equal to minus del V, and it is related with the help of gradient of scalar. In the magnetic field, it will be having electric field, scalar quantity and vector quantity, where in the case of electric potential distribution, the energy will be stored only in the capacitance as well as scalar quantity is only present. And coming to the application part, it is used in capacitance and microwave RF simulation circuit, and for the HFS application and CST application, this Poisson and Laplace equation will be used. And coming to the reference part, these are the references I have taken for this Poisson and Laplace equation distribution. Thank you.